Okay, we should be live.
Great. Sorry about the delay, everyone. We've had a little bit of audio issues, but welcome to Consensus Layer Call number 98. This is issue 660 on the Ethereum/PM repo. I think the most, I just realized. So Capella and 4844 are the things under concession, primarily under discussion today. And we have a few issues that we'll tackle. Meta Chris, you wanted to give us an MEV boost update and also have to leave early. So why don't we start there?
Yeah, sounds good. I will try to keep it short and only on the most important updates. There was the release of MEV Boost 140, which has a bunch of minor improvements, and the most notable feature is it allows setting a minimum bid value. There is more details in the release notes. Let me paste a link to the updates in the chat here. There's an upcoming post about implications and potential impact of setting various values. Otherwise, there's a proposal and ongoing progress on replacing the types in MEV Boost with those from attestant. Also related to the upcoming changes for Capella and EIP 4844, which have a bunch of payload changes, and we need to plan these in, and rather than duplicating the work with types in multiple repositories, it seems preferable to use the attestant ones. There was, moving to the relay, there was a vulnerability with incomplete block builder submission validations that led to incorrect timestamps or pref random values being delivered to CL clients. The CL clients didn't like them and fell back to local block production. I'm posting the full postmortem here in the chat now. So that's resolved. It's anyone using MEV Boost Relay, use version 014, please. That has all the solutions. Side note here, this uses the get random beacon API endpoint that is not yet in a tagged beacon API documentation, and not all beacon nodes have that implemented. So my ask is, consensus teams, please implement this endpoint. That would be hugely helpful.
Where is that documented?
1 second.
It's in the beacon APIs. Yeah, it's just not like an official release yet.
Okay.
Right, here's the link. It's only in the dev beacon API, and I think only Teco has this implemented yet, and Prism has the merge PR, but it's not yet in a release. Not sure about the other CL clients.
Got it.
There is big thanks to Justin Truglia. There is the relay API specs is now in the same format as the other specs, in an open API format in its own repository. We see another relay, relayor.wtf, gaining a little bit of traction. And they slowly ramp up their delivered payloads. About the builder ecosystem, there's a screenshots in the MEV Boost status updates notes that I posted, which shows that the leading builder right now is builder OX69, who delivers about 2,000 blocks in 24 hours, followed by the Flashbots builders with about 1,200 blocks per 24 hours, followed by Bloxroute, Beaver Build, and then a few others. There is a website Relay Scan that just shows the 24-hour statistics on an ongoing basis. And lastly, there were a bunch of Flashbots Relay updates. And we also open sourced the priority load balancer that may be useful for anyone running the MEV Boost Relay, which allows distribution of the block validations across a number of validation nodes with a high and low priority queuing. Okay, I think that's like a quick run through of the most notable updates, and I would be happy to take any questions.
Nice, thank you. I was just scanning through the execution APIs. Do we, and this is for anyone that's aware of it, are we doing the recipient diff? Is that in APR to be to come out maybe in the next upgrade of the execution APIs?
We have actually had a rough consensus to not do the diff, but do it in other way, just compute and just a sum of all transaction tips.
Okay. Got it.
Yeah, but it's still an
correct
extension.
me if I'm wrong. Yeah.
Is it that's still an extension to the engine API though, right? Like we'll update the get payload.
Yeah.
Or you were
Wait,
saying
what?
the CL. Well, I thought the EL would calculate the like. There's the question of like who will calculate this. Like if the EL is going to calculate, or like how. Sorry, there's a question of like how you calculate the value of the block, and then who calculates the value of the block. And so if the EL is doing it, regardless of the way they do it, we need to return it to the CL. But are you saying that the CL is going to calculate the sum?
I'm
Mikhail?
not sure if actually CL can calculate the sum, so it should
I
be
think they
returned
can.
by.
Yeah, I guess
Okay,
they
so
don't have the gas used for every transaction. But yeah,
nonetheless,
so
it
yes.
wouldn't be. It would still be a field. It's just a matter of what that field, the semantics. Of that
Yeah,
field.
yeah.
Okay.
And there was a PR issue for it.
Okay, I'll take a look. Any other questions for Chris? Okay, thank you, Chris. Really good info. Moving on. So I have Capella, and then I actually have a 484 issue under Capella. I'll move that. But we'll start with Capella. Alex or anyone else, can you give us the context on the bounded withdrawals sweep?
Yeah. So we recently changed a little bit how we're doing withdrawals. So there's no sort of formal queue in the state, and instead, rather than process things at epoch boundaries, you kind of do them every block. And right now, the version of the spec says you basically, in the worst case, sweep the entire validator set. So the obvious question then is if you want some bound on that sweep. And so there's a PR. Let's see, I'll go grab it. But there's a PR that basically introduces a sweep, and it's more just sort of like a RFQ at this, or RFC at this point. But yeah, we should decide if we want this or not.
Thank you. Any strong proponents want to make the case to get this in there? I know Potas and Daplion were on the PR, but are not here. My last comment was, that this does add a little bit of complexity, and I don't think there's currently a very strong case for the complexity, or at least the value being selected. That said, I'm only kind of weakly against this point. If we don't have the proponents on here, then I will take this up as a priority to get discussed over the next couple of days.
I'm here.
Oh, cool. How's it going?
Yeah, so quickly, I agree. I don't think it's critical. We have not run this on a main network, so it's not clear that this would be a bottleneck. It just felt nice from someone concerned with those issues to have that as a bound, but I don't feel strongly for it.
Right. So I wouldn't call it a classic DOS because it's not something somebody can induce on us. It's just like the maximum work that certain edge cases will have. But I guess the logic right now for the value is we have a validator set today. Some fraction of it we can reasonably sweep, thus bound it to that fraction that we know we can do. I
So
guess
the reasoning for it is in normal circumstance that value is completely relevant, but God forbids we may end up seeing a network situation where that value matters. And in a situation where that matters, it's probably where the nodes are already overloaded for adversarial network conditions. So having that gives some peace of mind. So I wonder what are the drawbacks of having that in?
I guess one thing is additional code that's almost never run, except in adversarial conditions. So then the likelihood of the code atrophying is higher. That would be my main thing.
Got it.
Yeah, so here's a question for CL devs, like if the validator set were double in size, is this an issue to have to like scan the whole set? Like, does that make you uncomfortable?
I guess we do that, right? We do that a lot on the epoch transition, but also a lot of work's been put into optimizing the epoch transitions and making sure we're doing it early and stuff. And I guess if we end up in a 4x, 10x validator set size here, are you going to have to put in a bunch of extra work to kind of do pre-computation on this?
So I think the issue is we risk having to do a full sweep per block, not per epoch, and that's more worrying.
Yeah, I understand that. And I guess I will take the other side of the argument now. If doing a full sweep would require, which we almost would never have to do in this case, would require additional like pre-computations and other special logic that would almost never get used, then that all of a sudden becomes more complexity that is potentially never having to be used or is being added even though we almost never need to use it. So maybe the argument is actually that these minor code paths prevent having to do all that additional complexity that we almost never need to use. So yeah,
How much more complex is it? Is it not as simple as a bound on a for loop? I mean, is that the complexity we're talking about?
It's not that bad. It's pretty simple in my opinion.
So there's like a second dimension too. So like the first thing is bounding the sweep, but then also there's a question of like, do we want to try to make it like fair in some sense? So you track where you go. And yeah, I don't know. Like it's not major, but I do feel like the full thing, does add all this complexity. And if it's just for this like tail case that we probably won't ever see, I think we have to ask if it's that important.
Yeah, I mean, so here's where I stand. Like, I'd rather do nothing, but if doing nothing actually means doing a bunch of like optimizations for this tail end case, then I'd rather do this. So if you think that if we don't add these code paths, it actually means we have to like highly optimize this for a tail edge case, then let's add these code paths. I've kind of changed my mind in this case. Very cool.
Do we know though? Like, do we know if clients will need to optimize like this? Anyone on the call want to chime in?
We haven't.
But we won't even have to know if we just put this bound. And in that case, I might argue for a smaller bound.
Yeah, I would need more time to properly answer.
Okay, so yeah, I think I was weekly for and I became weekly against, but it sounds like we're going the other way. So let's see. We can make a smaller bound. Well. And then also, does anyone care about this this fairness thing? Because then it does become like just very, very simple.
Because we're protecting against, sorry.
I was just gonna ask, like, what is the fairness component, like more concretely?
So like right now, we're like gonna start somewhere in the validator sets and go say like 2 to the 17 validators. The question is, if there are no withdrawals, do you just stay in the same spot every time, or do you want to advance your pointer 2 to the 17 every time? Does that
So
make sense?
makes an argument that this is not actually a fairness criteria. This is a mechanism criteria, because you could have a range, whatever that bound is, where everyone's already withdrawn and you can't withdraw them anymore, and it would actually get stuck. So this is in an edge case an unstuckness required criteria. To say, yes, it does help with fairness in the normal case, but there's an edge case that it's requisite. So I think I don't think it's to be debated. I think it has to go in if we do this bound. Does that make sense?
Yeah, it does to me. Okay, so I will keep polishing this PR, and I guess, yeah, we can just build more consensus asynchronously.
Sounds good. And because I think this code path will maybe never, fingers crossed, be hit on mainnet, we need to make sure we have a lot of good tests for it, so that in the event that it is, it's not atrophied. Okay, are there any outstanding Capella issues other than this bounded withdrawal sweep? Okay, great. Let's move on to 4844. This blob side car is currently mutable in gossip. There'd be two ways to fix it. One would be to do the actual KZG verifications at each hop. The other would be to reintroduce that sidecar signature. It seems like, due to complexity, especially rippling into validator signatures and stuff, that is the former is the preferable path here. So we do have some benchmarks that Sean and Kev have done on various operations in the issue. And I believe there might even be a PR that I haven't looked at yet. It's yes, 3108 that Sean put up there. Is there any outstanding discussion points that have not been made on this issue that people want to bring up? Or are there any questions for additional context if you're not caught up on this? Okay, so it does seem both of these operations, signature verification and the full aggregate verify, both scale with the size of the number of blobs here. Both on the order of 4 blobs per block look like a pretty reasonable amount of verification time with respect to what we're already doing at each hop. But both, especially on signature verification, if you're doing the full root calculation, and in the blob verification, scale to something like slightly more than what our verification time is per hop. There is one hack that's at least worth mentioning, the flat hash. So instead of doing the SSD hash tree root of the blobs for the signature, you could do a flat hash, which greatly reduces the time. But it looks like from this discussion and these benchmarks, we should probably move forward with just doing full blob verification at each hop. And if that becomes untenable, actually maybe discuss doing this flat hash each hop.
So in terms of scaling, right? The so the blob verification already does a flat hash. So and I think the rest of the computation, like so you don't have to do any KZG stuff per blob, or any like group operations per blob, or maybe a minimal one, like maybe one group multiplication, which is like a really small operation. So maybe, like, I mean, at least if we're comparing it to a full signature without flat hash, this might already be more efficient. than verifying a signature, at least asymptotically.
Yeah, I guess I don't know exactly where it scales to, but if you're looking at these benchmarks, which were done on different machines, we're for 16 blobs per block for the signature verification with the root, we're at something like 11 milliseconds. Oh no.
What is the
Sean.
marginal cost? What's the marginal cost per blob? Because I think my estimate is for full verification, it's about half a millisecond per blob marginal.
Yeah, on the signature verification, we're at 3 milliseconds, 6 milliseconds, and then 11 or 12 milliseconds for 4, 8, and 16.
Okay. So fairly similar numbers then. Yeah.
Yeah. And then on the full blob verification, I think we're at 4 milliseconds, 8 milliseconds, and 14 milliseconds for the same set of numbers. So it actually is pretty similar. And that's with the signature verification with the full root calculation. So with the flat hash, we're at 1.7, 2.1, 2.8, which makes sense that it's scaling at a significant subset of those. Nonetheless, I believe the general consensus is to move forward with full blob verification, as it does not really add any additional complexity. It also doesn't do, it pretty much adds no additional complexity. It's likely a tenable number at the lower end of the blobs per block, and we can get more data as we move into testnets. Is that the general consensus here?
Sorry, did we have any? Do we have any number what it costs for 16 blobs or 8 blobs versus 4 on full verification?
Yes.
And what?
Full verification is for 4, 8, and 16. It is 4, 8, and 14. Although he mentions that this is only 16.
That feels wrong somehow.
Okay.
Because I would expect that there would be a higher marginal cost for the first blob because you have to do pairings. So like the first blob probably should take like something like 3 milliseconds, and then additional blobs should be like half a millisecond or so. That's what I would expect.
Okay.
So that's why I'm surprised basically to hear that, oh, somehow it's more of a, like my expectation would be that it should actually become less of a problem as the blobs become larger, because like it's a very compared to donor.
I mean, if you look at some of these numbers between 11 and 16, it ends up like it goes 10, 14, 13, 13, 15, 14. So there's I think maybe some error here, and I don't know exactly how it would scale if we ran a bunch of these.
Dankrad, what did you say you was expecting?
I'm expecting something like 3 milliseconds plus 0.5 times number of blocks times number of blobs.
So each blob extra 0.5 milliseconds.
I don't know, like Danny's numbers just sounded very linear. That surprised me.
Well, they're Kev's numbers.
All right, sorry. Okay, Kev, let's discuss those benchmarks. That would be great. Let's see.
And help me understand how much parallelization is being utilized in this. Like, would I see similar numbers on single core? Go on, sorry.
Yeah, I haven't actually checked, but yeah, I do have 16 cores, so it's quite a lot.
Doncred, is that calculation utilizing parallelization?
I don't know. You can definitely parallelize it, but I mean, the numbers don't sound like it's parallelized because otherwise you'd expect it to. yeah, it agrees a lot more with more blobs.
Yeah. Yeah, I guess, to that, and the parallelization number would be good, but I'd like to know what this looks like, not throwing on 16 cores, which if that's where we're at, that's good.
Yeah.
Okay, well, let's circle back and just sanity check some of these numbers. As for the gossip validation, we can toss it in there. I don't think this is going to greatly affect our smaller test nets, but we might revisit it if we hit a wall with some of these numbers. But does that seem a reasonable path forward? I guess the only thing that we expect to come out of revisiting the numbers is actually a lower verification cost. Tancred? Which would be another check mark for going in this direction. So I'm going to review Sean's PR. Thank you, Sean. And we'll try to get this out soon. This isn't a blocker on testnets. Somebody could add an additional load on the testnet by allowing bad data to be gossiped, but I don't think that's what we're going to run into for the next month. So. Cool. Anything else on this one? Okay. I know we had the 4844 call, the weekly call earlier this week. But are there any other discussion items that we needed to bring up today on 4844? Okay, great. Mikhail has an engine API spec improvement proposal. Mikhail, can you give us the details on that?
Yep. Thanks, Tim. Okay, so quick overview. There is the issues here. Yeah, the proposal basically contains two main parts in itself. So the first part is the proposed change to the engine API itself. And it's just introducing the get caps or get capabilities method, which we came up to the workshop for DEF CON. And this method allows us, it basically returns the list of currently supported engine API methods supported by the EL client, and CL client just request this list and understand what's going on, what's EL version it is talking to, and what's to do next. So basically, this list allows us to introduce new methods, introduce them outside of like hard forks without any coordination efforts for upgrades of client software. Also, it allows to deprecate methods. So yeah, it's basically about this engine API change itself. And the other part of this proposal is establishing some kind of process of how do we want to, or how can we work on the engine API specs to make it a bit more structurable and reduce the degree of mess, anticipating the upcoming hard forks and all this kind of stuff. Quickly about this part. So what proposed is like, basically we will have a reference table of all methods that were historically proposed and were historically included in the engine API specs. This table will contain the actually the status of method, like is it like final or it's deprecated. Final means it's stable and should be implemented by every EL client. Or there could be experimental status, which is helpful for doing prototypes and all this kind of stuff. Also, the other part of it is like how the spec files actually should be structured. And what's proposed in this, what's suggested in this proposal is that we will have like kind of files with different methods required for this or that EIP, like EIP for 844, like withdrawals, and alongside the work is going around these features, these new features, and we are close. And as long as we're getting closer to the new hard fork, we create a new hard fork document. We put everything that we decided to be in the scope of this hard fork in this document. Then we do some rounds of iteration on this spec document. Then we finalize it after we decided that, okay, there is a spec freeze. We finalize this file, and we basically never change this file. The purpose of this is to have like a structured set of changes that we did to the engine API, and to allow for cross references between the files. So like, for example, Shanghai may refer to Paris and say that, okay, so this new payload method is basically the same, but we are changing these 3 things and just list them. So it's a kind of differential spec description. So it should be useful. And yeah, that's basically it. Basically, Live Client has a different opinion on how should we structure those files, and probably you can share it as well.
Yeah, my comment was just around the like overloading of the use of the hard forks as the organization mechanism for, you know, all the different RPCs. I think that this makes sense for people who are going in and just implementing these, so like client developers and stuff, because, you know, we've already sort of implemented all the past forks, and so we're implementing the new fork, and it kind of makes sense that this is like the minimal set of changes that need to be done to get to the latest. But I think it is not a great way of viewing the engine API and spec if you are not like very deep in like implementing these things. And I think this is like the similar problem that the CL specs have, where if you're just trying to go in and view what something does right now, it's hard because you have to like kind of start the latest fork and look and see if the thing you're looking for is in that fork, and then go back 1 fork and look and see if it's in that fork. And I'm afraid to like recreate that with the engine API, where if I want to see like what does get payload v3 do, I started some fork, I don't see it there, I go back another fork, I don't see it there, you know, and so it like goes forward in that way. So I think that if we do a logical separation of the different methods, so we might have a method that's like, or a file that's like blobs.md, and that would just have like all the things related to blobs, which is right now mostly just 4844, and then maybe like payload.md that has like all of the like new payload, get payload types of stuff. That I think is not much worse for client developers, because we can still say within the method, like, hey, this is Shanghai, or we can say in like the overview of methods, like these are the methods that we're doing for Shanghai. But to most people who just want to view and see what the engine API is doing, I think that that's a better way of interacting with it.
Yeah, well, I certainly see some really practical outcomes of this approach. So we will just basically have, if we are talking about new payload, we will have all the changes of this method in 1 file, and you can track them back and yeah, implement it easily. You will just have it on 1 screen instead of like jumping from 1 hard fork to another, figuring out what was introduced, say in Paris and Shanghai, what's needed to be implemented in Cancun if someone is implementing Cancun from scratch. I don't know. But yeah, what I like about these hard fork MD files is that you can just, you know, have it spec'd out and then finalize, and then just never touch this file and never change anything in that, unless there is like some bug that we want to fix. Yeah, also it's more aligned with like this feature approach. So if you have like EIP 4844 feature in a separate file, so you can just then yeah, it introduces changes to different parts of engine API. We will contain them all in 1 file, and we want to keep those changes separately from the main spec until some point in time when we decide to put to include this feature into a hard fork, and then yeah. So definitely functional approach, also functional oriented approach for these MD files makes sense to me. So there is a kind of trade-off.
Mhm. I don't feel very strongly here, but I do question who is the engine API spec for, and it, I would say, almost entirely is for client developers because it's not a user-facing API. You know, so as opposed to the ETH API where we want it to be organized such that it's highly functional for users to jump in. This is like, so I think should be optimized for client developers because it's not something that other people would be using. That said, I think both paths are relatively functional for client developers.
Yeah, I feel like if we have a list of these are the things that were added or changed for each fork, and then the file level organize it logically, I think that's the best of both worlds. Or, you know, vice versa, like have a list of like, these are the logical things within related to payloads and have the files as forks. I think just going with one of those approaches where you have both gives us the best of both worlds.
So when we were originally writing this, we kind of planned on moving it to a more functional description like the ETH APIs and like the Beacon APIs are, that can be better rendered and stuff. Instead, it looks like we're at least currently doubling down on Markdown. Markdown works for me. I don't really mind, but I do wonder if it's worth revisiting if Markdown's serving us as we wanted to.
Well, the proposal does have a like folder section for the OpenRPC definitions.
Okay, so we would do both.
Yeah, I think so.
Do we have the schemas for Paris or not?
No, we'll have to introduce them.
Okay.
When we will start applying this proposal, if we agree on it. And yeah, from my small short experience on like trying to put some specification for finalized, safe, and block tags into an OpenRPC description, it's really hard to spec anything in this form. So I think Markdown works better, at least better than OpenRPC specification. I mean, it's not specification, but schema.
I had a question. You mentioned a request for a list of methods that the client supports or the execution client supports. Not so much a question, but a comment. That's often not terribly useful because what users do often is that they upgrade their execution layer separately of their consensus layer client. So one thing that I think is useful is that we also kind of think a little about how to standardize error codes for something that's been deprecated and removed. And then how we reason about methods that don't exist yet. Because typically what we'll do as consensus clients is that if there exists a newer version of a method, we'll try the newer version first. And if that doesn't work, we'll try the older one. Or maybe the other way around, like it depends on where in the deployment phase we are, right? So calling a function that lists all the functions available is kind of useless if we can just try each one separately and see if it works, and then get like reasonable errors to pick one.
I think that JSON-RPC also already has this kind of error. So if you call a method, I don't know what this error specifically is, but yeah, this may also I don't know work, but it's just, you know, it just looks ugly from my perspective, to be honest. And
well,
yeah, and
it's reality, right? Because you don't like
it's reality, and sorry.
I think the core issue is here that we don't know when the execution client is restarted and upgraded as consumers. That might happen anytime. Like there is no
Yeah, I agree.
signal.
But it depends on the dialogue that you use. If you use WebSocket, so you may know because the session had got expired, right? And you had a new session established and can query every time the session has just started. You can query this list of methods. So for HTTP, yes, it is more complicated. I agree. And basically, yeah, and probably it is like falling back to error and calling a list of methods if you see that some method is unavailable or yet unavailable. Oh yeah, but it will not work if some method is still available, but EL has been upgraded and has new capabilities that it can suggest that can that can handle. So CL will have to query. So errors will not work in this case.
So sorry, guys. A clarification. My understanding is that the switch to the new V2 methods is quite dramatic. It's not a transitional period. So for all pre-Shanghai blocks, we should use V1 methods, and for starting with the Shanghai, for all Shanghai blocks, we should use V2 methods because the header hash will be different depending on whether there are like, even if it's there are no withdrawals, the hash of an empty list should be present. So it's not like a gradual switch to a new set of methods.
Yeah, I can understand this point pretty well because I was trying to make this point as well. And yeah, I think it's another thing to debate whether we want V2 to be backwards compatible to V1 or not. And I suppose that CL clients, they will be just easier for CL client developers to implement something like, okay, we see V2 method and we use it for every for every interaction after we request it and got that this method is supported by EL. Instead of like we should call to fork trigger whether this block is after the fork or before the fork to decide on which method we use. So I see like reducing complexity by having V2 backwards compatible to V1. But if this is not the case that we would like to solve, I would argue that we should, be clear on which method is called before and after hard fork. So just not making it backwards compatible.
I mean, backwards compatible is nice because then, like again, we can just try the new method. If it works, we get, you know, either the new data or the old data, regardless of if the fork has happened or not. In general, of course, that's not possible, but that's what we've done in the consensus, like the Beacon API a couple of times, where we upgrade, you know, between block V1 and V2, you could first query only phase 0 blocks, and then you could query any fork blocks, including phase 0. And that was very nice because then you just tried with the new one, and if it worked, it worked. If it didn't, then you tried the old one, and that's it. You don't make lists or anything, you just give it a shot.
Yeah. That's approach that maybe this is just, you know, can work out of what we have currently. I'm not sure. I've said that it just seems ugly to me and looks ugly. But yeah, it definitely reduces the spec complexity. I don't know about engineering complexity and the mess in the code that this like fallback would introduce. About backwards compatibility, I have a pretty strong opinion that we should not support more than like 2 forks in one method version, because like if we will support all forks and like V10 methods will, you know, contain all the logic that is needed for V1, V2, and so forth, that is going to be a huge mess. But backwards compatibility for like 1 fork is probably fine. again, if it reduces engineering complexity. So we need probably client developer inputs on the get capabilities method versus try and fall back if there is an error. And the other one is like the the other two things are backwards compatibility and the structure of the spec, basically. Hard forks versus functional grouping. Does anybody want to chime in?
Okay, based on this conversation and the current discussion in 3, 2, 1, Mikhail, are there any immediate changes you're going to make, or is it still in a good shape for other people to read and chime in at this point?
I think, yeah, it's still good to read, probably until next week.
Okay, and then how much is this a critical blocker as we're moving towards Shanghai, or is this something that won't block our development efforts? What's our timing criticality here?
That's a good question. I don't think it's blocking really anything right now, but yeah, we just need to start, like, if we're going to have some process, and yeah, the earlier we do apply it, the better for us. The less cleanups we will have to do in the future.
Okay. So please take a look this week if you want to chime in on this process. We might, I have a feeling we might not be able to get to it on all core devs next week, but maybe we'll throw it on the agenda. And if we don't, then in 2 weeks' time, we'll revisit this conversation. Sound good? Any final closing comments here? Okay, thank you,
from my end. Yep. Thanks, guys.
Now for general open discussion. Anything anybody wants to bring up today? Anything at all? Okay, great. Thank you, everyone. Talk to you very soon. Take care.
Thanks, everyone.
Thank you.
Thank you. Bye-bye.
Bye.
Thanks.
Thanks.
Bye.
Bye.
Thank you.
Bye.